Hello students, let's continue to our journey in food science. So for this presentation, we are going to change gears a little bit, and we have been talking about food composition, and we have been analyzing our selected product, and now we're going to talk about food microbiology and fermentation. So food microbiology is very important because we can think of microorganisms as having a positive impact or a negative impact in, say, processing and our health. And one of the positive impacts is through fermented products. And this is, we need to talk about food microbiology because before we dive into food processing, because food microbiology is such an important part of processing itself. So our learning objectives are to define fermentation and food microbiology, to discuss the history of bread and baking powder, to discuss the history of vegetables canning, and the H.J. Heinz Company to distinguish between foodborne pathogens. Okay, so fermentation is derived from the Latin word fervere, which means to boil, and it's a metabolic process that converts sugars into acids, gases, or alcohols. So there's many types of fermentation, and depending on the products that we want to get, we have to select specific microorganisms to do so. And also fermentation is the growth of microorganisms, and for them to be able to grow, we need a medium, or sometimes called a substrate. And we also have a specific goal in mind, or we want these microorganisms to produce a specific product. For example, maybe we want them to produce alcohol in beer or wine. Maybe we want microorganisms to produce lactic acid, like in yogurt. Sometimes we want microorganisms to produce acetic acid, for example, like in vinegar or in kombucha. So depending on what we want, we have to find both a substrate or a medium and a microorganism. And it is important to notice that even when we target a specific compound to be produced, there's a lot of reactions taking place during fermentation processes, not only to produce a specific compound, but also there's a lot of chemical reactions related with flavor. So fermented foods can also be defined as those foods that have been subjected to the action of microorganisms or enzymes to have desirable biochemical changes and cause a significant modification in food. And fermented foods are very popular nowadays because of the health benefits associated with the presence of such microorganisms and other metabolites and the impact they have in our health and in our gut. So in order for fermentation to take place, we need two things. First, we need a microorganism, and microorganisms can be yeast, normally lactic acid bacteria, or other microorganisms. When I say other microorganisms, we also have fermentation with molds, and there's different types of fermentation in, for example, biotechnology and bioengineering. But let's focus on the most common ones, which are yeast, which is used to produce fermented beverages like beer and wine, also used to produce in bread, and lactic acid bacteria, which is used to produce yogurt, and we also can have other fermented foods like I mentioned before, like kombucha and so. And then we need a medium or a substrate. So the microorganism needs food, right? So we have to choose the adequate food for the microorganism. So we have wort, which is the medium that is used to produce beer. We have grape juice, which is used to produce wine. We have milk, which is used to produce yogurt, and vegetables, which can be used to produce fermented vegetables and by the action of lactic acid bacteria. So moving on to food microbiology, we talk about fermentation, which is, let's say, the positive part of food microbiology, because we need microorganisms in order to produce fermented foods. So microbiology is the food division or subdivision of microbiology, and is related with microorganisms that are related to food. So food microbiology studies how microorganisms grow in food and how the environment has an influence on their ability to suppress, delay, or encourage the growth. So food processing is all about controlling the growth of microorganisms. In the case, for example, of fermentation, that's something that we want. We want microorganisms to grow because we want them to produce a specific chemical compound. But in some other cases, we don't want microorganisms to grow because they can cause deterioration in our food. They can cause us to be sick, and that's important to consider in food processing. So let's go back a little bit into the history of food microbiology. And this is a very, very condensed version. So between 1660 and 1670, Robert Hooke and Anton van Leeuwenhoek observed bacteria and fungus in a microscope. Then in the 1800s, the canning process is invented, and canning is one of the food processes that we still use today, and it's very, very important in our industry. Then in the 1890s, pasteurization begins. Pasteurization is also a type of food preservation method, and one of the best examples would be pasteurized milk, which we can find in the supermarkets in the refrigeration section, and we will talk about that more in the processing presentations. Then in the 1930s, home refrigerators are widely distributed. So refrigeration is one of the inventions of humans which are very, very important because they help us have extend the shelf life of products, and which is very, very important in all like our households and at the industry level. Then in the 1980s, E. coli 0157 was recognized as a pathogen, and this specific strain of Escherichia coli was discovered, and it is a very important pathogen because it has been associated with many outbreaks and recalls in the food industry. In the 1990s, the hazard analysis critical control point, which is a quality system, the acronym is HACCP, was required by USDA, and some of the industries that has used these are seafood industry and orange juice industry, and we're going to talk about more about HACCP in the next slides. And in the 2000s, the Food Safety and Modernization Act, also known as FSMA, was established as a preventive measure to help improve the quality of imported fresh produce. So let's talk about bread history and baking powder history a little bit. So as we know, bread is one of the commodities products that we eat daily, and bread can be produced by a fermentation process by the action of yeast, but it can also be produced by the addition of baking powder. So as we know, and as we have seen in our previous slides, so when we are making bread, we need yeast, and yeast was seen and discovered in between the 1800s and 1900s, and they were described as ovoid or egg-shaped fungal cell, and it was discovered that they were classified as eukaryotic cells, which means that they contain a nucleus. Then in 1847, even Horsford invented the baking powder, which he called yeast powder. And this was a very important invention. We still use baking powder, for example, for cakes and cookies, and it was a very important discovery. So as I mentioned before, when we make bread, we can have a fermentation process, and that is called, and for that, yeast is used, and yeast will interact with the components of bread or flour, and by the action of, or by the interaction with proteins, it will produce carbon dioxide, and that's what we talked about in previous classes, which is the gluten formation or gluten development. When we are not using yeast, we can use what it's called a chemical leavening, and leavening is the action of bread rising, so the formation of carbon dioxide, and the carbon dioxide being trapped in the gluten matrix. So one of the first companies that work with baking powder was called Rumford Chemical Works, and it was established in East Providence, Rhode Island. The use of chemical leavening had an impact in the bread baking industry because it is very predictable and reliable. So being different from fermentation, which sometimes there's a lot of like temperature to be controlled, and you can have differences in the final product because of like differences in the fermentation conditions. Chemical leavening is very predictable and reliable. So baking soda is what we know as sodium bicarbonate and HCO3, and we use sodium baking soda for some recipes, but for other household functions. And the difference is that baking powder is the combination of sodium bicarbonate plus cream of tartar, which is potassium bitartrate, and the cream of tartar is produced during wine production, and it's a solid sediment that is left during wine production, and it's derivated from tartaric acid, which is present in grapes. And then it has cornstarch as a curing agent to have more bulk, and it's used since 1850s. So in 1941, talking about the bread industry, there was this need of enriched bread. So we have been talking about how fortification of foods is so important, like for example, iodine addition to salt. So the fortification or enrichment of foods has also been a part of the baking industry. And the Title 21, Section 136 talks about enriched bread, rolls, and buns. So as I mentioned before, the enrichment normally is done with vitamins and minerals. So in this case, we have enrichment with B vitamins. The B vitamins are, we sometimes call them the B complex, and they are hydrosoluble vitamins, which means that they are soluble in water. So many of these B vitamins are very important for many functions of our body, and mainly in the nervous system. And its deficiency will cause a lot of health problems in the consumers. So thiamine B1, which is vitamin B1, riboflavin B2, and niacin B3, and folic acid B9 are added to bread for enrichment purposes, and as well as iron and calcium, which are two minerals that are very, very important in our health. And so bread is enriched with these vitamins and minerals because bread is a widely consumption product, and then we can assure that the population is getting all the micronutrients they need. So moving on into pickles history, and it has to be related with canning history. So pickles can be produced by two ways. One is by the addition of acetic acid, which is vinegar, in a canning process, and the other is by the fermentation process, which requires lactic acid bacteria that are native to pickles and a brine, and then the microorganisms will will perform the fermentation process. So in 1768, the British Navy Captain James Cook ordered that all his crew members should eat 2 pounds or 900 grams of sauerkraut each week. So sauerkraut is a fermented food that is produced with cabbage. So imagine like the surprise of his crew members, but something that happened is that sauerkraut contains 150 milligrams of vitamin C, and in these 900 grams of sauerkraut, which was the recommended. And so this content of vitamin C help prevent scurvy, which is a disease that is caused by the deficiency of vitamin C. So again, we're talking about deficiencies. So when people will not get enough vitamins that they need for the functions they require, and this can cause different illnesses. So this was one of the positive effects of eating sauerkraut, and some other effects were that crew members really enjoyed the flavor of sauerkraut, and as this can be a fermented product, it has also native microorganisms that can also help with digestion and so. So I just want you guys to think about like if you could really do this, like eat 900 grams of sauerkraut each week. Another important event that happened is in the 1800s and the journey to canning. So canning was developed by Nicholas Appert, and the idea of canning is to preserve food, to make food last longer. And as if we think about like canning industry today, we will see that cans can be stored before they are opened at room temperature, and they last a long time, sometimes 1 year, 2 years or more. And this shelf life sometimes is defined by marketing, not by something really bad going on inside the can. So cans can last for a very long time. So this is a picture of a glass bottle of, like, you can see it's very thick, and like the shape maybe not the best symmetry, but this was the beginning of canning, and with the idea of how to preserve food, make it last longer. So in the 1869, Heinz company developed canned pickles, and so they had these canned vegetables, and they made them in an industrial level. And this is also a canning process, but we've used not using tin plate cans, but jars. And this also helps, of course, as I mentioned before, extend the shelf life. And we have a product that is in an acidic environment, so normally a pH that is around 4.2 or less. And one of the campaigns that Heinz company developed was a campaign that was called "We've Got Your Pickle," and it was very popular in the 1960s and 1970s. So a little bit more about food microbiology, and we're going to get more into the bad microorganisms, or the bad bugs, the microorganisms that are harmful for our health. So again, there has always been a concern with consumers and their health, and how microorganisms can influence that. So this is just a campaign about washing your hands. And if you guys see today, we still have that with, like, in the restrooms. If you go like in fast food chains, there's always the sign of employees must wash hands. And so this is something that has been ongoing for a long time, and this is so important, and this is a part of food science, which is very, very important, and it's called food safety. So if we think about the most common microorganisms, we can classify them in bacteria, and they are the most common and most studied. Many of the pathogens are bacteria, but also some bacteria are used in fermentation, like lactobacillus, for example. The second one is yeast, which we have been talking about, and yeast and molds. So yeast is used a lot in fermentation, and molds as well, most of the time in cheese making. The other type of microorganisms are viruses, and sometimes they have been a little bit understudied due to non-scientific information. But there's a lot of like foodborne viruses that can cause illnesses. And the last one is parasites, which have also been associated with foodborne illness. So what can influence microbial growth? So we can divide these in intrinsic and extrinsic factors. So the intrinsic factors will be pH, and most foodborne pathogens cannot grow below pH 4.4. So that's why having a low pH will reduce its or delay its growth. And also other intrinsic factors are water activity, oxidation and reduction potential, and the preservatives that are added. So these are the things that we can control. And the extrinsic factors will be temperature, which is critical for microorganisms growth, and gases, which it's like air composition. And so, or we have oxygen, which or lack of oxygen, and this defines the rate at which these microorganisms will grow. So talking about the bad bugs and what is a microbial hazard. So a hazard is a potential to cause harm or be the root cause of damage. And a risk is the probability that a hazard will proceed to injury. So if we think as raw chicken, so raw chicken is a hazard because it contains the bacteria Salmonella. But if we fully cook the chicken, so we reach the required temperature to kill any Salmonella present in the chicken, there is no risk and therefore no injury to an individual. So this is how analyzing the hazards and the risks and how to prevent them is very, very important. So now let's talk about pathogens. So these pathogens are the bad bugs, the microorganisms that will cause us to be sick. So the first one is Salmonella. Salmonella is a gram-negative rod-shaped bacilli. It's present in warm-blooded animals, and it's commonly found in chicken or birds. And it can also lead to the contamination of foods. So Salmonella is like the best examples of Salmonella. It can be found in chicken and egg. And so these are the best examples. And when we talk about it, they can contaminate other food. We call this process cross-contamination. And this is an example of peanuts. So peanuts normally should not have Salmonella, but if we say process peanuts in contaminated facilities, or if workers that are sick are in contact with these peanuts, then we have this cross-contamination and we have what we call a Salmonella outbreak. And then this can also lead to a recall. And a recall is that when you retrieve the product from that you have processed because you suspect of the contamination with a pathogen, in this case Salmonella. So the next one is called Escherichia coli, and it's also a bacteria, a gram-negative bacillus. So bacteria can be classified as gram-positive or negative, and this will impact their structure, and mainly in the presence of cell membrane and cell wall. And this can also have an impact of how easy or difficult they are to destroy. So in the 1980s, E. coli, this strain of E. coli 0157 was recognized as a pathogen, and it has been of the pathogen that has caused a lot of health problems and outbreaks in the US and in the world. It is commonly found in the intestinal flora of humans and animals, so it's something that we have, everybody has. And some strands like E. coli that produces Shiga toxin can cause illness if we don't properly cook the food. So properly cooking of food is very, very important. And in some cases, if we think about restaurants, so if we go to a restaurant, they have to follow safety measures, and sometimes they have to take courses in food safety. One of the most popular ones is called Serve Safe, and they have to assure that when they are cooking chicken, meat, pork, seafood, they are reaching that temperature that they are required. And the temperature has to be measured in what we call the cold point or the cold spot. And it's normally around the center. And this is the part or the spot in which we expect temperature to take longer to reach the expected or the defined target temperature. So this is very important for food service. The next microorganism is called Clostridium botulinum, and this is a gram-positive rod-shaped anaerobe spore-forming bacteria, and can survive in. This means that it can survive in low oxygen conditions, and this pathogen is associated with improper canned foods, like for example in home canning. And why is it so important? Because it produces a neurotoxin which is very toxic and very serious. And we cannot see these bacteria because we cannot find any look, smell, or anything that is suspicious. But a small dose of these bacteria will be very toxic. So nitrites are added to deli meat to inhibit growth of these bacteria or of these bacterial spores. And a lot of food processing technology is designed around Clostridium botulinum. It is so critical to get to assure that our products do not contain these bacteria, because it is very, very toxic. So one of the last outbreaks of Clostridium botulinum was in a gas shop and nacho cheese. So nacho cheeses are processed by thermal treatment, and there was a problem with how employees handled the nacho cheese after it was opened. So there was nothing wrong with processing, but with the handling conditions and how it was dispensed, and temperature was abused. So it was left at temperatures that promoted the growth of Clostridium botulinum. So this is an example. It is very rare to have outbreaks of Clostridium botulinum, but most of the canning industry is designed around these bacteria. And then we have Listeria monocytogenes, and it's a gram-positive rod-shaped bacteria. It's present in ready-to-eat foods. The pH and water activity of these type of foods is very favorable. It is also present in cheese, ice cream, and milk, and it is very bad for high-risk individuals like pregnant women and the baby, or elderly or compromised immune system population. And it's also one of the pathogens that has led to outbreaks. So yeah, as I mentioned, dairy products are the place where we have a lot of Listeria monocytogenes growth. The next one is called Staphylococcus aureus, and this is a gram-positive cocci-shaped bacteria, and it's found in nasal passages. And normally the transmission happens with food service workers. So when they prep food, if they have the illness or they are sick, this can lead to the contamination of food, and that's very associated with washing your hands and the health of workers in the food service. So there's a lot of companies that will do regular checks to the health of their employees, because like checking swabs from hands or nose to see if they don't have, or throat, if they don't have Staphylococcus aureus, and they are healthy to prepare foods, because they're in contact with foods. And if they're not healthy, there can be a cross contamination, and thus cause an illness to the consumers. So this is just a final slide with some local finds, and we talk about some examples of the history of microbiology and a little bit of processing. So we have some examples of raw sauerkraut, which mainly can be produced with fermentation processes. So if we have claims like probiotic, this means that the foods have been fermented, because probiotics are the microorganisms that can help in our digestive system. We also have an example of kimchi, which is a fermented food from Korea, and 3 examples of bread. Now it's very popular to sourdough bread, and this is a fermented bread, and it relies on the natural flora of wheat flour or whichever flour we have, and the production of acidic compounds. And so we have these examples as well. So my questions for you today are: how are fermentation and food microbiology defined? What are the most common microorganisms in fermentation? How did baking powder influence baking? What is the history of pickles? What are the factors that influence microbial growth and recognized types of pathogens common in certain foods? So if you have any questions, please feel free to reach out, and see you during the next presentation.